Okay, I think we're on. So, hi everyone, thanks for joining this session. So it's Masterclass on link prediction in a knowledge graph, and that will be presented by myself, Christophe, and Laura from Stardog. So we thought we could start by introducing each other very briefly, and then also give you the opportunity to do the same on the chat. There's a chat box when you can drop messages if you want to drop online to say who you are. That could be interesting to let everyone know who is around. So Laura, do you want to go ahead and introduce yourself?
Thanks, Christophe. Sure. My name's Laura Firey Monroe, and I'm a product manager at Stardog, focused mainly on our front-end tools, so making knowledge graphs more accessible through interactive UIs and really helping democratize data and knowledge graphs throughout the organization. Back to you, Christophe.
Yeah, cool. And I'm Christophe, so I'm a researcher based in Accenture Labs in Dublin. I focus on data architecture and making knowledge graphs, and also take part in the graph machine learning activities of the team, so also predicting some things using AI on those graphs. And I'll try to share my screen now, if that still works. So yeah, to everyone, so if you want to introduce yourself, you have a chat. If you want to ask questions, there's a Q&A tab, so please don't hesitate to put questions there. And we also planned some dedicated time at the end to go through questions. And I just share screen. Okay. Yeah. Oh. Okay, I think my screen is going through. Good. So here we go. So what we have planned for today is first 15-ish minutes of quick overview of what we'll be talking about and the kind of general structure of the tutorial. Then there's an extensive hands-on session where we will invite you to work alongside with us to build a graph and then end up with a prediction in that graph to add new links. So it will be best if you have other tool at hand, which is essentially a web browser. That's all you need. So if you want to do that, so it's very progressive, step by step, and we'll do it together. And then we'll try to keep 15 minutes at the end for a last Q&A and some closing notes. And there's also an extra activity at the very end to give feedback about the session to the organizers of the conference. So you see a QR code with a form. So if we go through, so what this tutorial will be about. So we want to give you a kind of end-to-end approach to link prediction. So we end up with AI and how to enrich a knowledge graph with extra links. And we start with raw data. And we would like to guide you through the entire process, which is around deciding what goes in the graph and what doesn't, and using the AI, putting the graph together, all these steps. So we give you a general approach on a high level on both topics and everything needed. And we try to make it super accessible. So to that end, we'll use Designer from Stardog, which is a no-code environment. What we will not do today is go in depth into the topic. So we won't see everything Stardog can do. And we won't get into all the neat advanced things in AmpliGraph to make the link prediction even more efficient. We just scratch the surface. And then if you want to dive into both topics in more detail, there are links. We could put them in the chat. I hope/think you get access to a slide. We'll see that. If you have difficulties finding the tutorial, we can solve this at some way or another.
I'll add them to the chat, Christophe.
Awesome. Thanks, Laura. So essentially a tutorial bringing together AmpliGraph and Stardog each have extensive tutorial to go in depth. So you can dig into those, and you can ask us as well, even after the tutorial if you want. So we'll start with a use case. So we picked a data set, which you can find in Kaggle. It's European soccer database. And we'll ask a question, which is, could we predict which player could play for a particular team? So just to make the tutorial about something, that will be the topic of that tutorial. And the general approach we take is a very traditional one. It's this kind of three-step layer when you make a knowledge graph. So that could be like a knowledge scientist team will use that knowledge graph to make predictions and do the use case. And then we'll end up showing that. And we just use three components for that. We use Stardog to build the knowledge graph as a nice data fabric. We'll use ampligraph for the graph machine learning part, and we'll just use Jupyter as a quick interface to show the results. So if you imagine when this approach being scaled up in a company, you could have a team in charge of what you will do with Laura. You could have another team in charge of what we'll do together after using ampligraph, and eventually another team, but show the results in a nice way. It's more or less how we're organized in our team in Dublin. And so about connecting data, so we use Stardog, we do data fabric and an enterprise knowledge graph that we connect data sets. So I don't think, yeah, maybe you can see my consumer pointer now. So again, we won't get into the detail, but Stardog can connect to tons of data sources in different ways, put all that into a nice semantic layer that you can query. So we just use CSV files for today, but there's more that can be done. And then the key concept here is that we'll have a target ontology. So we take all this data and we decide on a data model, and we take the data and then we map this data to a target data model. So that's how the knowledge graph is built. And that, again, that goes just a bit beyond that tutorial, but just to see how that works. It's not like from day one you will aim at making the ultimate knowledge graph for the entire company. So normally when you do this kind of enterprise knowledge graph, you would do that in an iterative way. So start with a use case, see the concepts that are needed for that use case, get those concepts into the graph, then find the data set that populate instances of those concepts and iterate. So you will see in the tutorial, we start with this football use case and we start from scratch. But you could consider that at some point there will be another use case extending with more concepts, or that we will be starting from an existing fabric and say that for this use case about football, we miss this and those concepts. So it has to be seen always as an iterative process. So that first step of the fabric is a structure that you will see growing typically in the company as more and more use cases get cared for. And in terms of the machine learning, so we'll use ampligraph, which is a library which we developed in Dublin and open sourced 4 years ago now, I think. And it implements a set of techniques called graph machine learning. And graph machine learning is about taking a graph and then projecting it into an embedding space. So each of these dots is a vector of 200, 300 dimensions. And then once we have a space, we can do all kinds of mathematical operations to get what triples are most sensible to add. So here in that example, for instance, we can ask the AI what is the probability of Acme Inc. being based in Liverpool. And then we get a calibrated probability of 85% chances of that making sense. So you see from that graph, we can ask for that question and we get a probability. So it's a very nice hypothesis testing mechanism because you get an idea, would that triple make sense? And then you check against the graph. Essentially, that triple will make sense if based on the construction of all the other triple, that's the information that could indeed have appeared. So that's the tool we'll use for our tutorial. And especially for our tutorials, so what we need to do, you remember that question we say, could it make sense for a player to play for a particular team? We need to cast this thing into a link prediction case. So typically, and that's the reasoning we take in our team for every problem. We start with a kind of two target concepts. So do we want to link a player to a team? Do you want to link a gene to a disease? We do a lot of health projects. Do you want to link a beverage to a consumer? We did a case on customer segmentation for a beverage company. Every time you have that link, and then you start with that. We want a player plays for a team. That's your link prediction task. And then to make that, what you will need is plenty of instances of that. So that's machine learning. So machine learning needs example of the things to predict. So you need plenty of example of a player plays for a team. But also what we need is a bit more information. If we just give these edges, that will be a very hard project for the machine learning. So we need to find other concepts to go around player and go around team. And that's something you do halfway looking at the data you have and halfway looking at what you think or you wish you would have in the graph. So for the tutorial today, we found that to be a reasonable trade-off based on data available. So we'll have player play for team, and then the dataset contains plenty of match instances and countries. So each match can describe which player are in the match and which team are in the match. And then we can also know which match are in which country. So that gives more data for machine learning to try to more or less cluster things or position them into the embedding space. And you see, for instance, you could have thought that to make the prediction more accurate, it could make sense to take into account salary and budget of the teams, but we don't have that in the data. So it doesn't make sense at that stage to design that in ontology because we won't be able to instantiate that ontology anyway. So we skip those concepts. So that's the ontology we'll be working with. The data set is available on the website of the tutorial. If Laura, you don't mind putting the link to people if they want to already check it out. Otherwise, we'll come back to the link later. And that's mostly that's what we'll be building together. So build that graph first, and then that's the end result we'll aim for. It's a table that will look somewhat like that. And the idea is that we will test hypotheses. So you just make a link. Thanks, Laura. We'll make a link that says that player plays for that team. And then we will ask CompuGraph how likely is that. And by default, CompuGraph gives a score, which by default is not calibrated. So we won't get into calibration today. That's part of the advanced topic. So the score you get from CompuGraph, if you don't do anything fancy, is just a score. So the only meaningful use of that score is to rank. So here in that table, we ranked all these hypotheses by the order of their score, which in that example, when we took the screenshot, happened to be between 0 and 1, but it's not a 51% probability. It's just a coincidence. It's really a dot 51 that has no intrinsic meaning. It's just bigger than 46, which is bigger than 43, and so on. So by default, you rank by the score. And the very nice thing is that that's a hypothesis ranking. And then you could think of turning that into a graph completion task or something like that if you just test every combination possible. And you say, I complete my graph with 100 most likely, for instance. That's a way. But fundamentally, what we do is hypothesis testing. And we'll see at the end of that tutorial, we'll put together hypotheses and we'll test them all and run them all. Okay. All good with everyone? Cool. So if there's no question at the stage, I'll hand over to Laura that will get you to the graph creation.
Thanks, Christophe. Yeah, so as Christophe was mentioning, this is the hands-on portion of our discussion. So we'll definitely be rolling up our sleeves. So as you guys have questions, or if you're running into any problems throughout the tutorial, please feel free to use the chat, and myself and Christophe will be monitoring that, just to try and keep everyone together through the hands-on section. So I'm going to start. Christophe, I think just with the tools, you'll need to stop sharing for me to start.
Indeed, sorry about that. I stop and I let you share.
No,
I see that someone mentioned the link to be broken, so I investigate that as you start explaining.
Okay, thanks, Christophe. And we'll be starting off with a couple different links initially, so we'll get back to that one, but we have some time. Perfect. So you should start seeing my screen. And the first thing that we're actually going to get started with is getting a Stardog Cloud account. And we're doing this so that every one of you will have access to a knowledge graph. And we're going to be using Stardog for that environment. So if you could head to cloud.stardog.com, and I'll post that just in the chat link as well. You'll be taken to a screen to go ahead and welcome you. If you don't already have a Stardog Cloud account, you can sign up or continue with Google if that's your email provider. And so once you sign up, you'll be asked to just fill out a quick profile. Once you sign in, you'll be taken to a welcome screen that looks like this. Because we are going to be checking out and getting a Stardog Cloud plan, which will include the environment that we'll be using in today's tutorial, you will need to verify your email. There should be a pop-up that just helps take you quickly over to your email, but if not, you can navigate to your email that you used to sign up with, and just verify that email. And just in terms of how that screen looks. And just once you're starting to get signed in and you've verified your email, if you'd like to just add the reaction of a thumbs up or another reaction, just to let me know that the group's all signed up. Awesome. I'm seeing a bunch of thumbs up. So we're going to go ahead and start moving forward. Again, if you're starting to meet any issues, feel free to use the chat to ask questions. So going back to our window, we're going to now sign up for a Stardog Cloud environment. And so I'm just going to use the screen back here. Sorry about the transitions. We'll want to select a Stardog Cloud plan. So this blue button at the bottom of your screen, you'll move forward. And for today's session, the free environment will be more than capable for this data set. So if you click on Get Stardog Free, you'll be taken through a cart process. There's no need to enter a credit card or anything like that, but you do need to check out. And to officially check out, you will have to have verified your email. So again, just once we're all together, just start sending me some thumbs up in that chat. Once you get Stardog Free, you should be taken to a homepage like this. Yours will likely read Stardog Free, and then you'll see 3 tools, some quick actions, and metrics. Awesome, I'm seeing some thumbs up. So it sounds like we're all. So I see a note about the server is overwhelmed. Yeah, so if got it. So we just wait a moment. We do allocate these automatically, but certainly with everyone signing up, and in just a few minutes, there's a lot of load on the system. Um, so let's just give people a moment and let me just check in. All right. So if you are having trouble, just wait for the server to respond, and you should hopefully be able to get a free instance. We can also share a portion of the designer project that's already created, so you won't miss out on the end um, piece with Christophe, or if it takes a moment to provision your Stardog free environment. Perfect. So switching back to our presentation, we're going to go ahead and talk about the three different applications that we have here. So Stardog comes with those three applications that we're seeing on the previous screen. So we have Stardog Designer, which is a no-code visual environment to model and map and publish your data for your knowledge graph, and that's what we'll be using primarily today to do our modeling and then mapping. We have Stardog Explorer, which allows you to explore your knowledge graph, and this is also a low code, no code tool. So there's a variety of ways in which you can explore your knowledge graph within Explorer, whether that's through follow your nose interactions from the graph, or building more complex queries through a query builder interface. And then we also offer Stardog Studio, which is a complete IDE to program your knowledge graph. We'll briefly show some of the capabilities within Stardog Studio, but primarily today we'll be focused on Designer, and then, of course, the AmpliGraph piece. And so we're going to start by opening Designer. So if you click on Designer from your Stardog Cloud homepage, you'll be taken to Stardog Designer, and then you can select New to start a new project. And we'll all do that together and start a new project called Tutorial. So I'll click on Designer. I'll have quite a few projects just from my work, but your Designer screen will probably be blank down here. And you'll select New and input tutorial and go ahead and create. So once we're here, again, if you could just send me some thumbs up that we're all together. Yes, I'm seeing some people are still having trouble allocating their Stardog free instance. Um, so we'll continue monitoring that, and hopefully circle back there. So moving forward with our project. Just as a quick overview, Stardog Designer is a tool to help you model or build an ontology for your knowledge graph. And it also supports mapping to that ontology. And so today we'll be walking through both of those aspects. And so we'll be adding concepts, sometimes referred to as classes as well. We'll be adding relationships between those concepts. We'll also add a few attributes. We'll add inference rules. So if you're unfamiliar, knowledge graphs support inferencing, which is business logic that is run at query time to infer new relationships or attributes associated with your data. And so that's one way that business logic can be built into your data model, and therefore accessible to all of your end users without them having to write that into their end queries. And then we'll also map in raw data to use. And so starting out with adding concepts and turning to our data set, so as Christophe was talking about, we'll be using a data set that was originally posted as a part of Kaggle for European soccer teams. And what we're going to be doing is predicting links in between players and teams that they could be a part of based off of matches they've been in. And so we'll be transitioning from a relational CSV type of view of this data, so columns into concepts, and so that class graph view. So starting out, what concepts we'll be using within our data set as part of this data set. So if you were to go to this predicting links and knowledge graph link and download this data set zip, there'll be a few different CSVs within that. We'll get to the CSV part, but if you want to go ahead and start downloading that, you may. And a few of the CSVs that we'll be using are tied to concepts like country. So that will just become a country for us. Match is a heavily used concept within the knowledge graph we'll be building, because match will also help us associate different teams that were a part of that match, but also players that were a part of that match. We'll also use the player and player attributes CSVs to build a concept around player, and then we'll use team to build the concepts around team. So jumping into Designer, we're going to be adding a few classes, and we can do this together. And so with the Add Class button here as part of your toolbar, you can go ahead and add a new class. And we'll add classes for team. And we'll just add a couple of these classes for country. A class for player. And a class for match. At the end, you should have 4 classes. I'll just jump back to our slides for a moment. 1 for match, country, team, and player. So if you're with me, just I'm seeing a couple thumbs up. You guys are getting the drill. Thank you for doing that. And then just from the once we're set there. So again, if you're looking for the data set or some of the slides, if you were unable to get a Stardog free instance and want to try this later, that GitHub link that was posted earlier should take you to this page, which has our slides and data set here. So then moving forward, our next step will be adding relationships. And so we want to add relationships in between those classes that we just added. So we want to describe what that relationship entails in the name, and so that any users viewing this can understand what that association is. And so we'll be using relationships that are directed. So they have a domain or a source node, and then they have a range, which is the target node. And so we can go ahead and start adding a few of those. This is the end result, but we're going to walk through adding these links. So if we jump back to Stardog Designer, we can go ahead and select match, and we'll select player. And so with both of those selected, we can go ahead and add relationship. When we're adding relationship, we can add one for home player. We'll add another relationship for away player. And let me just, yeah. And then so we've now got our away player and home player between match and player. And now we'll go ahead and do this for team. So add 2 more relationships for home and away team. So again, we'll select match, and then team. And then when we add relationship, we can select home, team, another relationship for away team. And then we have just two more relationships to add. So between match and country, we'll add a relationship takes place in. And then we want one more relationship that associates player and team. And this is the link that we're going to be predicting. And so we want to select both of those objects. And then, and again, the source should be player and the target team. And we'll make a relationship for plays for. Jumping back to our tutorial, we've now got our 4 classes and our 6 relationships. So hopefully everyone's with us now. Thank you, Christophe, for adding the original link of the data set there. I'm seeing a couple thumbs up follow through, so thank you for keeping me posted. Perfect. So moving on, we're now going to be adding a few attributes. And so for this, attributes are one way to add properties or literals, sometimes referred to. So they're data types added to your concepts. They can be a number of different data types, such as strings, integers, or timestamps. And today we'll be adding specifically an attribute for a player called rating. And we'll just make that a float. And so if we go over to designer, we can double click on our concept player and we can add an attribute for rating. You'll need to select create here, and then we'll add float as the data type, and then we'll add this attribute. Just a keynote there, you do need to add it. And so once it's added, you should see a square show up on your player node, and if you were to select that, you would see rating. So today we're just going to be adding one attribute, but you can imagine that there could be many more attributes that we added to each of these concepts, and that would just help us have more information to feed our model or to share throughout our organization. So one question that comes up of, should I be modeling this as an attribute on my data or as a relationship? And it really depends on what you're trying to achieve. So in this quick example here, what we've done is show kind of 2 different ways of modeling, say, a theme that is a part of a website on a web page in 2 different ways. So maybe a theme is just an attribute where you'd want to filter and have the ability to specify what a theme of a web page is, but maybe there's more information that you want to surround theme, such as there's a hierarchy, so parent themes within your web page, or maybe you want to be able to relate and link themes. And in that case, you'd likely want to use a relationship with another concept for theme versus just an attribute. So an attribute is one great way to associate additional data with a concept. But if you really want to use that data to connect to either itself or more data, you want to have pass through that piece of data that you're adding into your knowledge graph, we would recommend a relationship. This obviously makes your graph more complicated, so that's where the trade-off is. And so the question becomes, how do you want to use that piece of data that you're mapping in? Is it something that is connected and you want that hierarchy, or is it just an attribute that you would be filtering on and does not need to be connected or organized in a more hierarchical way? And so our next piece that we'll be doing is adding rules within Designer. And so if you've written rules before, rules are one way that you can add business logic within your graph. And so we'll be doing that within Designer. And rules are written in kind of an if-then pattern. So we'll describe a set of criteria in which a rule should be run, and then we'll specify what result we would expect when that criteria is met. And so we'll focus on the if-then portion, and then when this graph is used within Stardog, that will be evaluated to determine the association. And so we're going to be adding two rules, and we'll walk through this in Designer as well, but just as a high-level view. We'll be adding rules as part of this rule detail drawer. And just a note here that rules will not be executed when they are created. Instead, rules are evaluated when a query is run. And so that way, they're always evaluated against the most up-to-date information within your graph. It's not something that you need to refresh. So we are going to jump over to rules. To Designer, and we'll select our rules button up here in the toolbar, and we'll create two rules. The rule name is really for you, and so we'll go ahead and create player plays for, and we'll call this home. And then in our rules builder, this is a very similar interface to within Explorer for building out queries using a no code pattern. And so this is just going to give us concepts that are available within our model and help us build logical associations between those. So we're going to go ahead and say a player that is a home player for a specific match. And then that match has a home team. So home player and home team there of team. Then we want player to play for that team. So once you've built that out, we can go ahead and save. So again, that's player is the home player of a specific match, and that match has the home team of a team. Then that player plays for that team. And so all we're doing here is inferring the plays for relationship between player and team. We can go ahead and save. And then we're going to create a second rule for away. So player plays for away. And again, we'll select player, but this time we'll say away player for a specific match. And that match, away team, team. And then we'll infer that that player plays for a team. Okay, so now we've got two rules once we save this one for away players being associated with their team and one for home players being associated with their team. Perfect. So again, our results are those two rules. And then we're going to just pause. Sorry, pause here for a moment. It seems like there are some more free instances being allocated. So if you weren't able to get one, I would suggest trying now. It looks like our system's caught up. I'm also seeing some thumbs up. So hopefully people are now with me with the rules. And so we'll go forward and publish our ontology that we just built. And so we can go ahead and switch back to Stardog Designer. we'll go ahead and select this publish option. You can export on your own if you want to later. Export will give you a download of your model that you just created, as well as the rules that you created. So your Stardog endpoint, if you just signed up for Stardog Cloud today, you'll just have one that will likely be called Stardog Free, but it should look similar to this pattern here. And then we'll go ahead. You likely don't have any databases, so we'll go ahead and create a database. So we'll call that tutorial. We can leave model namespace selected. AirMeet is covering this for me. Okay, I can move that to the side. And so if I'm going to toggle this off, but if you did want that download of your zip project, including your model, you can go ahead and leave that toggled on. So then we're going to select next. We're going to create a new model because we're in a new database. And we do want to include our inference rules that we built. And we can go ahead and publish. So now we should get alerted that we successfully published. And then we're going to switch over to Studio just for a moment to show another way in which you can view your model. And so if we open up Stardog Studio, again, this is the IDE for building within Knowledge Graph. And so we're going to just switch over to what is our Models Hub. So that will be your fourth selection down. And if you select on that database that you just published to, so tutorial, we'll be able to select tutorial as our graph. You can set a namespace, but since we're not editing this model within Studio, you could also leave it as read only if you wanted to. But I'm just going to go ahead and confirm the tutorial namespace that we published. Then we switch over to our text editor. And this is just going to be showing the turtle that was written to our knowledge graph, defining the concepts, relationships, and attributes, as well as rules that were added within our model. And so this is just another way to view your model. Or if you needed to come in here and edit something, though, again, Designer can also be used for that editing, and we'll show that. So jumping back to our slides. Now we're going to be getting to adding some data. So right now we only have the model published. We don't have any of our data published. And so we'll just paste this link one more time in the chat. And so from this GitHub page, if you can go ahead and download the dataset zip and unzip that, that is where we'll be selecting our CSVs from to complete our mapping. So once people have that downloaded, just send me some thumbs up that we're all together, because it's important that we have our data. Awesome, seeing a lot of thumbs up. Perfect. So we'll start moving forward. And so we're going to upload 5 CSVs. And so if we jump, so just those 5 CSVs that data set includes a few more CSVs, but we'll be using country, match, player attributes, player, and team. And so we'll jump back over to Stardog Designer. We're staying within the same project, and we'll be adding project resources. And note here, you can also use Stardog to connect to different data sources, such as Amazon Athena or Databricks. But today we're doing CSVs just to make that a little bit easier. The CSV upload is one at a time. And so we will have to do this 5 times, but we're just gonna go ahead, select the file that you want to upload. So I'll start with team. You'll be shown a preview, and we're just gonna go ahead and say create, not create and map at this point. So we'll go ahead and create, and then we'll upload the rest of the files, and we'll just do that quickly, and then I'll meet at the end. So player attribute, player, match, and then seeing country within there. So I want to make sure that we have country file. So then plus country, go ahead and create. And so we have our 5 CSVs here. Switching back over. So once you have those 5 CSVs, if you could send me just a thumbs up. Seeing a lot of people getting their instances allocated. And so I will note this code within, if we go back for a second. So if you are just getting set up with Stardog free, we're just going to take just a moment and walk through how you could potentially bypass this mapping and modeling piece. So if you click on this code and additional files in GitHub, you'll be able to download this export from designer.zip. And within this zip, you will have a file with an extension .stardog designer. And if we were to just open designer up, instead of selecting new, you can select the drop down and import project. And then if you import that .stardog designer file, you will be taken to a complete project of what we're working on today. So if you weren't able to join us in the beginning, that's one way in which you can still be working live with us now. So hopefully that will get you caught up. Or if at some point we lose you throughout this, that's one way that you can see that final result of the project and come back to this. So just going to exit that out and then go back to our tutorial. So again, we should have those 5 CSVs uploaded. Yeah, and it seems like country was not included in that zip, the data set zip, Christophe.
Yeah, I'm on it. That's odd, but I'm on it.
Okay, so we'll go back and map country in a moment. And so we're just going to move forward with some of the other mapping pieces and hopefully catch up to that in just a second. So going back to our slides and moving forward. So we're going to map a few of our pieces, and Designer offers a couple different ways that you can map. We're going to start with our team mapping. So if we go over to Designer and we select team, which is our project resource, we can now select this add mapping button. The mapping name is really for you, so this isn't used in your final Stardog instance, but we can go ahead and make this legible. So we can make this team mapping, create, and we'll be given an arrow that we can drag to our team node. So interactions within the canvas there to start our mapping. Now we can highlight that mapping and toggle to our mapping view. And we'll be taken to a mapping page specifically for our team class to the team project resource. Stardog also offers a suggestion service to help you associate your data set to your class, and so you can select that. And so we would have a primary identifier of ID and then a little label of a long team name. What this suggestion service is not aware of is that we actually today want to be using this team API ID. And so we'll select the team API ID and exit out of the team ID that was suggested. And then if you are doing this by hand versus the suggestion, you will want to select team long name. And again, if you did those suggestions, you will need to accept them. So hopefully now everyone was able to map team with the team API ID and the team long name as the label. And I don't think we've covered this. Label is what we'll be using to help make a human legible label for these class instances. And so this label is what will be used in, say, Explorer when we're exploring that graph in a canvas view versus what is the primary identifier, which is a more computer readable ID. So then another way to add a new mapping is to select new mapping as part of this mapping page view. And we can go ahead and select two of our resources. So country. Oh, we don't have country yet, so I won't do country. But we can go ahead and do player and player. Okay. And we'll just select that. And when we run this new mapping from this new mapping option in the mapping view, we'll go ahead and suggest mappings for you. Again, we will want to select the API ID, not the ID for player, and then we'll leave player name as the label. So for the primary identifier for player, we want to make sure that we're selecting player API ID. Okay. And now we'll go ahead and do that once more for player attributes. Select player. So if you were not to select a class in the second option, we would go ahead and select we would model a concept for you. But because we already have concepts created for these resources, we do want to set that. We'll go ahead and say next. And in this case, for player attribute, we actually don't want to add in a label, and we'll leave player API key as the primary identifier. And then we have a rating as well that we will want to be mapped. And so that's the attribute for our player that we're leaving in. We'll go ahead and check mark that. So from player attribute resource to player, we have the primary identifier player API ID, and then we have the rating, overall rating set. So now we'll go into new mapping again, and we'll select match as well as match. We'll run suggestions for that. And for this one, we weren't able to get suggestions. So we'll just go ahead and select match ID. And then we actually want match ID for label. So that did come through there. And then match is where we'll be mapping our relationships as well. So we see our relationships here. And so this one, we'll have to select the target class for each of our relationships. And so for away player, that target class is player. And then we're given an option to set the primary identifier of that target class. And so we will need a new mapping for that. And then for away player relationship, we want the away player ID. And we'll just do that a few more times for each of these relationships. So away team, we have the target class of team. For the target identifier, we'll want that to be the away team ID. And then same deal for the home players. So we'll go ahead and select the target class player, and we'll select home player ID. And for home team, we'll select team, and then home team ID. So again, if you're with me, you want to just make sure away player, right? Away team, that those line up. So then for our last relationship here takes place in, that is associated with country, and we'll select country ID. And I'll just pause here a moment because I know that's a little different than some of the other mappings that we've done. And I'll just check back in with AirMeet and see where we are with awesome. So I see that the data set is also now complete in that link. So we're going to then just take a moment. We'll jump back here, allow people to re-download that data set and upload the country CSV. So I'll stay on designer with this match team up and allow you guys to do that. Once you're able to upload the country CSV, if you could just send me a thumbs up reaction, and we'll just give people a moment to catch up there. Awesome, already seeing some thumbs up. Wait for a few more. Again, if you're having trouble, just feel free to reach out in the chat. Awesome. So while we give people a moment to catch up, I'm seeing a few more thumbs up. But while we wait, we can certainly go over some of the mappings that we've done. And so I'm just going to toggle back to our model view. You'll see that a lot of our classes are now blue. Designer does tend to make everything a little bit smushed there. So we can spread these out. Make sure we can read them. So I'm going to just walk through a few of these. We had been on the match screen for a little while, so we'll start with player. And so if we, oh, sorry about that. So if we select player here and we move over to our player mapping, we'll see that for the player CSV to the player class, we should have the primary identifier player API and the label player name. This list on the left here can sometimes be confusing, especially when your concepts and your resources are named very similarly. So you'll see this is a 3-level hierarchy. The first level is the resource name. The second level is the model concept that you've mapped to. And then the third layer is that actual mapping. So here we see then the player attribute resource is mapped to player. And then we have that as a part of the player attributes player mapping. And so for the player attribute CSV, we want the primary identifier to be set by the player API. We have not mapped label, and we do have the overall rating mapped to rating. For team, again, we have a team project resource, then we have our team concept, and then we have our team mapping. The primary identifier here is team API key. Our label that we're using is the team long name. And then we'll jump up to match. And now we see 4 different concepts that we map to, because we have matched the project resource, and then we have all of the different model concepts that have been mapped either through relationships or directly from this project resource. We're going to just view this from the match view. So if we select match, then match, and then match, we have a primary identifier for the match mapping set as match ID. We have a label of match ID as well. And then we have our 5 relationships mapped here. And again, just as a quick overview, we would want away player map to player, right? That's going to be your only option. Same with away team to team. And then each of these, you'll notice that as you go back to this screen, we'll have the target identifier associated with an additional mapping. So if we wanted to check what we used for away player, we would need to select player. And we could check both of our mappings under player and see that for away player, we've used the away player ID. And then for home player relationship, we've used the home player ID there. So now we're going to jump back to our model view. By this point, I hope everyone has their country CSV uploaded. If you weren't able to upload that, or if we've lost you along the way, again, please use the chat. And we'll just add one more mapping for country mapping. We'll go ahead and create. And then from that arrow on the canvas, we'll drag that to country. We'll select that country mapping line that we have, and then we'll switch over to our mapping view. For country, we'll set the primary identifier of ID and a label of name. So that's our last mapping that we'll complete. So hopefully everyone's with me, and we'll jump back to our slides here. And again, through suggestions, another way to map within Designer. And we've mapped our relationships. Again, if you're thinking about how to select these, if you're on, say, the away team relationship, you want to select the away team ID as the target identifier. And so now we should have our end result that looks like this. So all 4 of our classes should be blue, indicating that our mapping or a primary identifier has been set. And then so for match, we should have 1, 2, 3, 4, 5, 6 mappings associated with our match CSV, and then just one mapping associated with each of the other CSVs. So how are we doing? Are people with us? I can get some thumbs up. I'm seeing some thumbs up. Awesome. Great. So now we'll move forward, and I think this is one. Okay, so we'll pause here. Sorry about that. We need to publish once more. So we'll go back to model. And this time, when we select publish, we'll have one more option in this step for configuring our mappings. So again, your endpoints should be pre-selected. Your database, you'll want to select tutorial or whatever database you published to last time. We can add this namespace. Up to you. If you download the zip of your project, your zip will now also contain the mappings that we associated with each of our concepts. We'll go through next. As long as you stay in the same project, we'll go ahead and suggest that you just replace the existing model. We will do that now. Again, we'll be publishing our inference rules. And then for each of our mappings, because we don't have any mappings within our data sets, we're just going to create new. We're going to select create new for this configuration for each of these. So no need to change anything here. Then we'll go ahead and publish. So we'll take a moment longer than last time publishing, because we're also publishing all of our data and writing that to Stardog. And so once that's complete, we should get a success toast down here. So we're just switching back to our slides. And at this point, I'm going to hand it back to Christophe. Though we'll just give people a moment to catch up and thumbs up if you're with us. Awesome. Seeing a lot of thumbs up rolling in. I'll stop presenting and hand it back to you, Christophe.
Yeah, thank you. So if everybody is on board, I share my screen again, and then we'll start looking at our data to see what we have. So, sharing, we just start with that. So we start with Explorer. So if we return to Stardog Cloud portal, you can pick Explorer, which is another no-code environment here aimed at clicking around and see what's in the graph. So we do that a bit. If we do, so if you select your tutorial and you just press visualize, you see a nice view of the ontology. So that's a good entry point. So we can just to be the position. So here you see that the ontology we made in Designer with Laura, and then you have all of it presented here and all the instances of the data. So I think that's the next slide. If you click, so for instance, here in the side we have player. So if I repeat that here, if I right click on player, see the details, you can see all your players with their names. So that's the names, and then you see on the names, that's the label that was configured in Designer to have something nicer than the identifier. And if you see when I hover on one of these players, you can see on the bottom left of the screen, there's a URL shortcut, and then you can see that this player is called tag Stardog Designer Tutorial Data Player 2768. So that's the otherwise name. So that's why we need labels. Otherwise, it's not super intuitive. And then you can pick any player. You can click on that person, for instance. And then you could do something like that, send to graph. And then you switch to seeing what's happening with that player. So apparently that player was the home away player for 12 match, home player for 14. Then you can do other things. You can see what other match. You can ask to expand that bubble with, let's say, text space in. So that will, all this match took place in England. So you all of them. So that's a way to just see what's in your data set easily, you see, without typing any. So the default query language for graph in RDF, the technology used by Stardog, is Sparkle. So here we didn't write a single Sparkle query so far. And what else was? Yeah, that was to see any sort of a match. So if we try that, if we pick one of them, pick that one for instance, then we can see all the data from that match, for instance. So there's one player missing, 10 away player, 11 home player. The away team was Everton and the home team was Manchester City. Does that work for everyone? Yeah. And what else? Oh yeah, just a quick mention. Again, not something we see today, but to check that you have, for instance, 11 players over time, you could write what is called the shape definition. It's something called shackle. And then shackle will be run against your data set and raise alarm if something doesn't check out. So it's a very nice data quality tool. You could see the shackle interface is, just keep to read only here. It's something to be defined here and then to be validated. There's an entire constraint validation capability in Stardog. So again, not something we see today, but something good to know exists and worth digging into deeper after the tutorial if you're curious. And lastly, quickly, what we can do here is do some advanced queries. So if I return to Explorer, you can do query builder. And then the query builder here, let's do the same. There was country take place in, that's a match. What did we do? Match as a team, match as an away team, and that's a team, and that's it. And we run that, and we see, and we'll see all the match with their country and team. So you can do a more complex query with plenty of conditions, again, without typing a single line of Sparkle. So that's a good tool. Like in Accenture, we're very happy with that because we can show that to every stakeholder on a project. That's a super accessible way to see if a knowledge graph makes sense. That's a tool we are very happy to use. Did that, and let's just switch to Studio quickly. See, we're a bit behind schedule. So we just run that. So if you see in Studio, you can select your text reasoning, and then for instance, that will return your triples from the dataset. So that's the triple that are created. So if we switch to, skip that just to have more time for the link prediction. So that was to show you that the rules are processed backwards when you ask for the data. So it's a very powerful system which will ask against your dataset last minute and so on. So for those of you that are aware of this backward chaining and forward chaining things which are normally run, there's nothing of that here happening, at least not in a pre-run style. So it's a bit of backward chaining on demand. So now if we go to the next step, so and I see there's a question that's probably for you, Laura, so I'll let you take that one. So let's go back to predicting our links. So we want to predict if a player plays for a team. But one issue we have is that, so we'll use AmpliGraph. AmpliGraph cannot at the time process attributes. So that rating we put for a player, we need to turn it into a node. Otherwise, AmpliGraph won't be able to make sense of it. And then once we have it into a node, we need to group it by range. And we call that making buckets, because for AmpliGraph, a rating at 1 and a rating at 2 will be as close as a rating of 1 and a rating of 200, because they're just labels without intrinsic meaning. So when we create this kind of nodes, we need to bucket them to give them a bit of more information so that they could be grouped more meaningfully. So we create nodes for rating, we do a rating range, we simplify that relationship here to just say that match has been played by that team. We don't need to make the difference between home and away. And then we extract some more information. So that is to, if you like, it's the feature engineering step of other machine learning techniques. We extract and customize a bit the graph to make sure AmpliGraph has all the information needed to derive, to extract the signal from what we need. So now what we'll do is that we'll go into Studio and progressively put together the triples we need for AmpliGraph. And so there's a few queries, and you can test them one by one. And if you want, there's a final one available on the repo. So the final query is here once we put everything together. And you will just start with that one. I'll show you how it works. So if we do, so let's take that bit and we go to Studio. And then we just select, we put that query. So here we just say, give me a triple. So now we get into doing Sparkle. And then we say, I want just my predicate to be either the first or the second one. And that doesn't work for me. Yeah, because I maybe change something of the model. So maybe I just return 2. Just explain how it works here. So you have to do like I did, make sure that matches the prefix you use for your predicates in the model. Be sure you get triples. So that filters over triples with either of these 2. And that's triples we just take as is, not rewrite. So we just say take filter predicate to have these triples. Then there's that relationship away home that we want to simplify into a single one. So that one, you can do it with a query like that one, where you say, give me that relationship. Again, I want either of these 2, but every time, just put that one instead and return the triples. So construct is a Sparkle query that creates triples out of other triples. So it's to turn triples into new triples. And so maybe because we're running short on time, and just to be sure we cover the end, I want to highlight that the output is here. So if at the graph prediction step you want to just load the data, is that file graph content.csv.gz. So I just quickly fly through that. So turning a literal into a node, so that's the thing we discussed. So we take the value of rating and we need to turn that into a node in the graph instead of an attribute. And here the main thing to be careful of is to put some kind of prefix. So here we put rating so that a value of 1 that becomes a node is a rating 1. And like if you have age 1 or number of medals 1, that's a different type of node, because otherwise you get super nodes, because a 1 could be anything in different contexts. So that's why you need to prefix. Then we have the buckets, which is actually doing some math to bucket by 10th. And then that's the kind of end query you could run. So if you do that, that would, you could put something like that in Studio. And then in Studio, what you would do is run to file, you run in CSV, and then you get your tuples that you can load into AmpliGraph. Makes sense to everyone? Maybe thumbs up or yeah, cool. Thanks for a thumbs up. I'm sorry, I think we have 12 minutes left or something like that, so we won't have time to run everything together live. So I just fly through what needs to be done and explain, and then if you want to try that at home later, and if you have questions, please don't hesitate to reach back. So to run the prediction now, what you can do, so we have a notebook here with the entire solution. So maybe I just guide you through that notebook. And you can do the same. You can do on Google Colab or something like that easily. And the main things that you need to do, so load the data and then prepare the data set. So let's see through the notebook how that looks like. So you import everything. So AmpliGraph is based on the TensorFlow. So you need to install TensorFlow. You need to import AmpliGraph. You will get these versions. So we are currently at AmpliGraph 2.0, which is based on TensorFlow 2. Then you load the data, that's regular CSV load, when you can see your triples. And then the first thing is to make a model. So here we do usual train validate, because we want to train AmpliGraph on that data, these triples, and then check that AmpliGraph actually learned something. And the entire goal of training step for a graph machine learning model is to train the AI to recreate the graph. So we show the AI plenty of triples that are in the graph. So these ones. And we show some that are not. So that's called the coefficient triple. So for instance, to create a coefficient triple, you can take the first one here and swap the subject and the object. And we tell to AI, we say, look, that triple here, SPO, is in the graph, but OPS is not. So we say, that's good, that's bad. And then we do a differential optimization. And we do plenty of that's good, that's bad, that's good, that's bad, until we get to a model that has learned what is good and what should be created as triples. So that's the entire training logic. So what we do here is that you take something like 10%, usually it's a good rule of thumb, 10% of your training set to run this test to see if the machine has learned something useful. And then here, that's a generic approach. We tune the hyperparameters a bit. So you need several components in the regulator, a loss function, an optimizer. You assemble everything up, and then you train your model. So then that will take some time. You see there's a loss function that decreases nicely. And then after a few minutes, you get a model. And so generally, we advise people to run that on GPUs. That's way, way faster. On this tutorial, considering the size of the data set, you should have a good experience with a regular CPU. And also TensorFlow can be optimized for M1 or M2 max if you have any of those. So at the end, you get the model. And if we, I'm just seeing that question, what is value? Yeah, so the AI, so it's a hypothesis validation. So you can use that in different ways. Here we have a use case when we want to predict, could a player play for that team without make any sense? So we leverage the graph to make those predictions. And you could have different use case. We did use case in Accenture around drug discovery, where we had clients suggesting different targets of interest, and then we could rank them up by their likelihood to target the disease they wanted to target. And that works out quite well. In a way, it's you've seen Laura explain this if-then rules. You say if, then create that triple. So that is nice if you know the business rule. In a way, you can use GraphML to do the inverse, to say I want the then, but I don't know the if. So if we have the if, we say if that player has this and that player could play for that team, then that's easy. If you don't know the if, you can ask the then part anyway, using these kind of techniques. And then the AI will figure out what is the if. And then you could deploy explainable AI technology to even have a real materialization of that if you want. Hope that answers the question, Pat. And to calibrate and so on, Franklin, I would suggest you to have a look at all the tutorials we made for Ampligraph. There's plenty of details to dive into. We definitely won't have the time today, but hopefully that can answer your questions. So if we make a prediction, you see we have these kind of things. So if we look like, for instance, a VAT metric, if we ask for 100 links, we get 50% of them, which are good. So that's common metrics to evaluate these kind of models. And then you see if I switch to the predictions. So what we formulate here, we just get the list of teams, team of player. We make possible pairs. We remove the ones that were into the training. And then that's all our hypotheses to test. So here we formulate plenty of hypotheses, and then we just ask Ampligraph to run them all. So you just say to Ampligraph, now predict me a score for each of those triples. And what we get is this value here. So you see that we get that these 5 first triples are the ones that will make most sense in the graph. And these bottom 5 are the ones that are the less likely to be true. So there's some of these questions, there's a player. So you see that's not super intuitive. We'll get to that in a minute. But that player 33473 playing for that team 9837 is very unlikely considering everything we have in the graph. So it could be that that's a player for some country that could suddenly transit to another country, but they never played in matches together and so on. So they are very far away from the space. So it's very unlikely that that player could play for that team. And that one is quite likely. So you see that's all you get. And you see in that one, it's a bit different from the screenshots you have in the tutorial deck. The scores are between minus 92, 092 and 268. Because we managed to tune a bit more the hyperparameters, they get a better model. But you see here, they're not calibrated, so it's really only meaningful to rank. And here that player was Lionel Messi. So if we check for him, that we get some labels now. So just to show you on the labels how you can do that, you can actually connect to Stardog directly from your notebook. So here you have the instruction. You need to just store your own credentials for everything, and then you can connect to your instance of Stardog Cloud. And then to get the labels, you can write a Spark query like that one, where you just say, select URI label from all the context. I want the DFS label set in Designer. And then you get a nice dict using pandas. And then you can just do replace labels. And suddenly it's much more accessible. So again, so in terms of real world example, if you switch to the tutorials from Ampigraph, we listed everything there. So you can see example in this beverage company we work with. You see example in health. There's a few examples. We take the time to dive into in that deep dive for Ampigraph, Aniana. That's okay. It works quite well. It's we picked an example that where maybe that could be overkill to use that technology on that use case, but that was to have a simple use case to have something easy end to end, easy to grasp. But like if we quickly, if you go there, and then we have our tutorials just to show where that is. So if you look like here, classification, we have coding, we have a number of example and code snippets and so on. So please have a look there. There's plenty of examples closer to real business use case. Yeah, and then the raw score into percentage, and it's called calibration. So here you find documentation how to calibrate your model so that you get actual percentage of likelihood between 0 and 1. It's just something that was a bit overkill for the tutorial today, but that's something we can definitely do in Ampligraph. So adding labels, we just did that. And then you see at the end, we can see, so apparently saying that, so I'm not a football person at all, but saying that Tom Stark plays for Stade de Reims is very, very unlikely. The resources, if you mean the tutorials, that's the first two links that Laura put in the chat. There was the link to the tutorials from Stardog and our tutorials. So I can put them now. I just try to close that because we have a few seconds left. Oh, calibration, okay, I give you that. So yeah, so let's stay in touch. There's an invite here to clone the repo, share things, feedback if you want to. Here also for Stardog, if you want to look at the knowledge kit, that could be something interesting to explore. And then we wanted to drop a note on the LLM, so that's something new to Stardog. But to make Bachelor even simpler, you could chat with designer to get your model sorted out and your queries as well. So that's something that would be for a future revision of the tutorial. And so I think we are on time. I think we had one last request from the organizer of KGC with a QR code to get feedback. So we'll probably get to that now. And what that shows up, Pat, I search for the link to the calibration in our documentation. Yeah, thanks everyone for attending.
So I'm seeing a few chats come in and a few people still on the line. So I think you can connect just with direct messages. So feel free to direct message either myself or Christophe if you have any follow-up questions. And then I can just answer one of these questions live. So Stardog does provide some automation for creating a map from different services. We saw this a little bit within the suggestion service. You can also use that to build out a full knowledge graph for concepts. We have this as part of some of our demo days. So if you're looking on stardog.com, there are some historic webinars that are captured there, but I'll also take that one back to our team as another presentation we could consider.